4 analog output controller. So it's all still in the same 1U size, so the frame hasn't changed. It's a little bit wider, a little bit deeper, as you'll see when Brian presents. But in the end, it is 16 channels in nearly the same form factor as the VR9500. We have expanded some capabilities. We talk about high channel count systems. This box will be sold as a 16 channel system, and then you can stack them in 16 channel increments. So 16, 32, etc. The first point that you see up there is that it can go up to 256 inputs. So this expands our high channel count capability. Right now, with the 9500, we can do 128 channels. With the new 10500, we will be able to go to 256. The next application would be multiple shakers. We'll talk about some of the output configuration, noisy systems. This is a cool feature that is going to have some capability and fairly soon, and hopefully will spark some conversations with amplifier companies. But we have a digital output that can be used for control. And then we'll talk a little bit about the controller analyzer combination and some advanced configurations. So let's jump right into that and start talking about 16 plus channel systems. As I said, the max input count will be 256 inputs. One of the neat features or interesting features is that we can connect up to 3 VR10500s to each other without requiring a network switch. There is integrated capability, so as you can see in my drawing, I can connect 2 additional secondary 10500s, so my channels out to 64, no, 48, sorry. My math is a little slow this morning. Up to 48 channels without a network switch. So this is going to expand our capabilities, and again, 256 inputs will also give us the opportunity to target some of those higher channel count applications. Multiple shakers. As I said, it has 4 outputs, 4 analog outputs. The first release of software will essentially work like a 9500. The additional outputs will be for COLA type applications. But as we continue to develop software in the upcoming year, we intend to be able to do all of the multi-shaker applications that we can, plus 2 more outputs. So you could look at 3-axis systems, a tripod system, single dual phase shakers, 3-phase, so 3 shakers all moving together, 4 shakers all moving together, and also have the multiple loop outputs. So I could have those 4 outputs either phased or independent control loops. And this is going to give us a lot of capability. There is future development that needs to happen in order to make all of this function in software to the appropriate amount. But this is very exciting, and it gives us the opportunity to really start targeting some of these multiple shaker systems where previously we had to use multiple VR9500s in order to accomplish that. Now, with all the outputs being from a single box, we use the same PC, the same control hardware, and it's going to give us a lot more capabilities to develop software for. Digital control output. This is something new and unique. So the digital control output, I have it highlighted in the bottom, is an SPDIF output. It's a digital audio standard. The idea here is that we can break the ground path between the controller and the shaker that would typically be carried by the BNC cable. That is one of the most common ground loops that is created in vibration controllers, and being able to break that allows us to partially isolate and eliminate one of the biggest potential noise sources in the system. This digital link has 2 additional channels, so it can be converted into 2 analog 24-bit channels and gives us that ground isolation. What will need to happen, and is currently in development on our end, is a converter box, essentially taking that digital SPDIF output and converting it into the analog signal that can be then sent into the amplifier. Our goal is to set this up as an example for amplifier companies to use in the future, that they can integrate this digital input on their amplifier, so we can just have a digital cable that goes directly between the controller and the amplifier without having to add our own converter box on the other end. The primary benefit of this is the breaking of the ground loop. Next is remote inputs. Very similar to the capabilities of the VR10500. So you have 8 digital or analog remote inputs. They do have a little bit higher voltage range. 10 volts is what we talked about yesterday. So they can take up to a 10 volt input. But we've also added some additional capabilities, like supporting a tachometer, either 2 single tachs or a quadrature tachometer, and have added some time stamping capabilities to those inputs. But in the end, this is very similar to what we have in the VR10500, with the expanded voltage range and the additional time stamping and then support for tachometer. That tachometer support is especially important when we start talking about analyzer systems rather than straight controller systems.
And quickly, if you guys have questions, feel free to write them into the chat, and we can answer them at the end of this section. And otherwise, at the end too, we can unmute people to speak, so it's not just you listening to us talk the whole time. So, thanks, Jake.
All right. Next is remote outputs. We have added quite a bit of capability to the remote outputs. So it is a digital output, and internally it functions very similar to what the VR10500 does, in that the output will have a tri-state output on, off, or open, and it outputs a 5-volt TTL voltage. The new capability with digital outputs is that we now have the ability to feed in an external power supply and you switch that external power supply through the digital outputs. Meaning, if I have 24-volt relays that I need to switch or control, I could connect an external 24-volt supply, feed that into the back of into this DB37 pin connector, and route that through a digital out, so now the switching voltage is 24 volts, roughly half an amp. And that would give us the ability to drive 24-volt relays and switch 24-volt circuits rather than having to stage that and switch the 5-volt relay to connect a 24-volt system. Next is dual software platform. I talked a little bit about this. We are currently, I think yesterday we released Vibration View 2020.1.4, so if you have not downloaded that yet, feel free to download that and start using that on your demo units. There is some new capability there. I'll be doing a webinar on the new release here in the next week or two. But also ObserView, the data acquisition side of the world, has a new release that is in final validation right now. And that new release of ObserView is going to include a tool called Live Analyzer, meaning I I can feed live data into ObserveView, view the time stream, and then all of the frequency graphs that you have in ObserveView. So FFT, PSD, transfer function, transmissibility, cross spectrum, all of those graphs, you can use the live analyzer capability. There's also some additional tools like peak-hold FFTs and PSDs, spectrograms, that all can be enabled. So that gives you the ability to do live and analysis functions on top of using this as a controller. And the VR10500, just like the Observer1000, will be a dual software platform, meaning that it functions in ObserveView or VibrationView. And just kind of to touch on a few other applications, the increased power channel count is going to give us a lot of new opportunities. So one of the questions that has come up in the past is, in sign-on random with the VR9500, we are limited to 4 tone response channels, meaning I can see the tracking filtered sine tone, tracking filtered measured sine tone on the sine tone profile graph, but that only works for the channels in the primary box, so 4 channels. With the VR10500 and the Observer1000, you can view up to 16 sine tone response channels. We've also discussed adding virtual channels for limiting. One of the other limitations of the VR9500 was with force limiting, where we wanted to combine multiple force inputs and apply a notch function to that summed force. We now have that ability for up to 16 channels, so you would still need 1 control channel, but then you could essentially add 5 triaxial force sensors and do limiting on the combination of those. We are working to improve the user interface for higher channel count configuration. So VibrationView is currently set up for lower channel count systems. There are some modifications that can be made to make it easier to set up high channel count systems, and we intend on doing that in the upcoming releases of the software. Next is the input impedance ranges. So the 0 to 20, plus or minus 10, and plus or minus 1 volt are the same 100k ohm input impedance, but we've added a plus or minus 5 and plus or minus half volt with 10 megohm input impedance. This is going to allow you to connect DC or MEMS-based accelerometers and have much cleaner readings with that higher impedance. So this is primarily for the MEMS sensors. Talked about most of this, but this will be an initial release. Will not have most of these features. This isn't really the slide that I was thinking it was. I apologize for that. But there are new features and capabilities, and it is going to require software development. The initial release, which will happen in September 4 is when these will be available for sale. But the initial release, it will function much like the VR9500. There are some added capabilities, but primarily it will function in software the same as the VR9500. These are things that we will look to add fairly soon after that initial release. But again, all things take software development, and that takes time in order to do it correctly. So just kind of my conclusion slide here, target markets and kind of the applications that we were designing this for. A lot of aerospace, large products, airplane wings or fuselage bodies, tail assemblies, rockets, missiles, satellites, multi-shaker systems, high channel count systems, and then advanced computation systems. As Brian is going to talk about shortly, this box, this new 10500, has a lot more power than the VR9500 even, and is going to give us some additional capabilities for math functions and math applications. Oh, wrong one. There we go. At this point, does anyone have any questions about the initial presentation and the applications, and having an understanding of what we are targeting with this? Otherwise, I will turn it over to Brian.
Yeah, and just to remind you guys too, this isn't meant to replace the 9500. We still intend on selling the 9500 indefinitely. It's still going to make more sense to have a 4-channel 9500, but once you start getting to 12, 16, and above, this is where we intend to sell the 10.5 almost exclusively. But as Jade said, if you guys have questions right now about the first presentation, put them in, and we can either unmute you or just answer it via the GoToWebinar. Let's see. There's just the one. All right, we'll turn it over to Brian. Brian is the main hardware engineer that developed the 10.5. You can give some background on yourself to these guys. I don't know if most of them have ever met you, so.
Yeah, sure. Thanks, Aaron. Yeah, my name is Brian Brezan. I've been working here at VR for the last few years, doing hardware design, including this VR 10500 we're talking about today. I have a background in actually aerospace mostly, so I'm used to designing high reliability type products. So that fits pretty well here. You might have to clear right click. You have to click into the PowerPoint. Oh, okay. I'm a newbie to doing these kind of presentations. So this next presentation, we're going to talk a little bit more in depth about the 10500 hardware itself. As Jade mentioned, we're really targeting the more advanced customer setups for these, the high input channel counts, the more complex drive configurations, multiple shakers, more complex phasing requirements. So we've added a lot of features to support those applications. We really had an opportunity with this to do a full kind of from the ground up or from scratch design. We were able to pick and choose the features we liked from the 9500 and from the 10500 and combine those together with the extra features and requirements to support these more advanced applications. So to go with that, we have a quad-core processor, quite a bit more powerful than what we have in the 9500, which is just a single core. The observer is kind of right in the middle with a dual-core processor. We ended up having a pretty big change going from the 9500 to the observer and the processor architecture, and so we're sticking with that going forward for the 10500, just kind of stepping up to the more powerful version of that processor. To go with it, we have
in listen-only mode.
I need to, all right. Thank you, Aaron. To go with that processor, we have DDR4 memory, which is kind of the latest and greatest right now. We also have the ECC configuration. If you're not familiar, that stands for error correction code. And what that allows the processor to do is detect errors in the data stored in the memory, and in some cases even fix those on the fly. Errors in the memory are pretty rare, but they can also be pretty catastrophic. So that's a feature we had in the 9500 that we're carrying forward. You see that in high-end computing platforms, real high reliability type things, so that's a good fit here. You might have noticed on the last slide, we still have the ring lights around the input BNC connectors. We've expanded that capability a little bit. So in the 9500, they are just red and green. If you turn red and green on at the same time, you get yellow. You can play with the intensities and also get orange, but kind of limited in colors. We now have red, green, and blue. So in addition to just adding blue, that also opens up colors like purples, pinks, white, cyans. It'll give us a lot more options for feedback to the operator. Still require a cooling fan, but we've upgraded to a quieter cooling fan to help with some of those noise-sensitive applications. I was going to use the arrows. So here we can see the 10500 and the 9500 right next to each other. On this picture, on the 10500, we're still missing the stick-on Mylar labels. Those are coming in next week, actually. But only you kind of see we've got the same sort of look and feel. We tried to make it very similar, both aesthetically, so you kind of know it's a VR product, but also, so if you're familiar with hooking up a 9500, it's hopefully somewhat intuitive to hook up a 10500 as well. Like Jade said, you can see we've made it a little bit bigger with all the extra inputs and outputs. We had to add some more space to hold all those connectors. So what we've done here is we've expanded out the width of the controller to fit a full, kind of full standard equipment rack. With the 9500, it's a little narrower. So when you put those L-shaped brackets or ears, whatever you want to call them on, they fill in the gap. Here there's no gap anymore, we just take up that full standard equipment rack width. It is rack mountable, correct, and the height is the same, it's still a 1U. So if you look at it, we're getting 4 times as many channels per 1U. So for like a 128 channel system, which is our max for the 9500, which takes, almost a full floor to ceiling equipment rack, now you're at about a third of a meter in height for all those, so it definitely consolidates down quite a bit. We also had to go just a little bit deeper to help fit some of the extra electronics required for all these extra inputs and outputs. It's actually a half-inch deeper, which is about 1.5 centimeters, so they're pretty close in depth. Looking at the inside with the cover off, if you're familiar with the layout inside the 9500, this is very similar. We have external AC power coming into a standalone power supply, which gives us a low voltage DC, and that's what we use to control all the circuits inside the controller. We have this big main circuit board right in the middle that's red. That is kind of really the heart of the whole thing. It has all the analog and digital signal processing, handles all the communications for the Ethernet and interbox, all that kind of stuff. And then we also have a front panel circuit board, which is down on the bottom in this view, just like the 9500, that holds the input BNC connectors, handles the LEDs for the front panel lights, as well as the status indicators. We have pulled some of the components forward from the main board onto this to help improve performance. So some of those components are EMI filtering components. These are the ones that help mitigate some of the noise issues in noisy electrical lab environments to help them perform better. We've also pulled some of the protection components for the front panel inputs onto this board. Some of the components that we see damaged on repairs and returns coming back to us, we pull those up to the front panel board so that hopefully when we have severe damage, more cases we can just replace the front panel board instead of having to do really complicated repairs, or in some cases scrapping that big main circuit board, which usually requires us to just scrap the whole controller. So we've got a more maintainable, more reliable design for this configuration. So getting into some of the more specifics on the front panel inputs, 24-bit analog to digital converters, that's just like the 9500 and the Observer. We are able to step up to a max sample rate of 256 kilohertz, along with the same 200-volt input protection we have on the 9500. For input modes, the single-ended, IEPE, TED, those all work just like they do in the 9500. But we did choose to go with the simpler front end that we have in the Observer, where we don't have direct support for cab-coupled or differential mode. But we are planning to add a software-enabled differential mode. And the way that will work is you will take 2 input channels and combine those to make one differential input in the software. And that will work very similar to the way we do a differential output in the 9500 right now, where you take the drive and the cola and you wire them together to get a single differential output. Very similar, just as on the inputs.
Mm-hmm. And that was a conscious decision by us, because we don't see very many users using gap couple.
It does. It takes, to support those two extra modes, we end up with a fair amount of circuitry in the board. So this helps simplify things, make it more reliable, a little more cost effective.
Yeah. So cap couple is actually supported by the 0 to 20 volt input range that he's going to get next. The purpose of cap couple is to strip off a DC component in the signal. So if I have something else that's powering my accelerometer with the IEPE supply, and I'm feeding that raw voltage into the controller, it's going to have a, let's just say, 12 volt DC offset, and then the analog signal coming back on top of that. The 0 to 20 volt range is also what's in the Observer 1000, but that 0 to 20 volt range replaces cap couple and functions exactly the same. We're just doing it in software instead of physically tying capacitors into the circuit. So functionality, if you're looking for cap couple mode, switch to the 0 to 20 volt range, and it will function exactly as if you were in cap couple.
Thanks, Jade. So Jade went through these input ranges and input impedances. I will bring up, so Jade mentioned for the 0 to 20, which is typically for IEPE, and the plus minus 10 and the plus minus 1, we're at 100 kiloohms. We do get questions occasionally about why 100 kiloohms and not something higher, something in the mega ohms. And the reason is we've really optimized this for IEPE use, and to get low noise with the 200 volt input protection, that really optimizes out at 100 kiloohms for this application. But like Jay said, we've added, like we did with the Observer, we've added a couple high impedance modes for those applications that just need to have that higher impedance where you're not doing IEPE. So you have some options there.
Yeah, and we did that because we generally find there's tenders and specifications around the globe that are requiring people to have above 1 mega ohm or up to 10 mega ohms. So this now satisfies that requirement.
Right. So looking at the analog outputs here, we were actually able to step up to 32-bit digital analog converters. That's pretty cool. We have a max sample rate on these of 216 kilohertz. And with the 9500, we have two output ranges, a plus minus 12 and a plus minus 1. Here we've consolidated that into a single plus minus 10 volt output range. So looking at the connections on the rear panel, Jay talked about some of these I/O, so I'll just add a few things. Looking at input power, just like with the 9500, we can support 110 volt AC, we can support 220 volt AC, 50 hertz, 60 hertz. Works just like the 9500. We'll use the same power cord as the 9500, so you just need to have the right power cord for your region, and that's interchangeable between the 9500 and the 10500. We talked about the wired cooling fan. Jay talked about the 3 Ethernets so that we can support up to 3-box 48-channel system without having to add a network switch to simplify things. We do actually have a USB connector on the back, supports USB 2 and USB 3. Initially, we don't have any customer applications we're targeting there. We do use that for when we have brand new hardware that's just been assembled, doesn't have any software. We actually use that USB port to load the very first initial round of software into the box. But it's available if we have the right customer application. That's something we could look into there for standard USB peripherals. Interbox, just like the 9500, when we get to the higher channel count systems, to synchronize the internal clocks, we use this interbox system. The connection scheme is very similar to the 9500. A little bit simplified in that in the 9500 you have specific out and in ports where you need to take the output of one box and connect that to the input of the next box. And you keep chaining them together that way, output to input. Here the ports are interchangeable. There's no in or out, so when you chain them together, it doesn't matter which connector you use. The remote I/O or the aux inputs and outputs. Jay talked quite a bit about these. The only thing I'll add is that the connections are almost identical to the 9500. With some of the new features, we had to add just a few new pin locations or change a few. But all the big ones are in the same location. The 8 inputs are in the exact same location. The 8 main outputs are in the same location. The 5-volt bias is in the same location. The grounds are in the same location. We still have the hardware emergency stop where you actually have the jumper inside that you have to pull off to use. That's all in the same location. There's just a few new pins for some of the TAC and the where we feed in the optional power to go to higher voltages on the outputs. But for any applications that you might have or any kind of wiring setups you're familiar with, those should transition very easily and in most cases will be identical. And Jay talked a lot about our outputs where we've got 4 analog outputs. We have this new digital output that will support 2 more drive channels remotely at the amplifier, so not a lot to talk about there.
And if you guys have requests for certain applications or uses of the USB, don't hesitate to send them in to us. We're kind of an open book with that right now, I would say. So
All it takes is software.
yeah, that's all we need. And if there's a request and a need for it, we'll develop it.
All right, so that was kind of a quick overview of the hardware, some of the specs. I didn't want to get too deep and bore everybody. Hopefully everybody's still awake. But I'm happy to go. If you have questions about anything, I'm happy to talk more in depth about any of those interfaces.
Yeah. If you can, I think we can see, if you go to the attendees, we can see if anybody raises their hand. Oh, somebody raised their hand. Go to attendees, raise their hand.
Where do I expand it out? Oh, attendees.
And you scroll down. Let's see.
They just over it, so we can unmute over.
Over, your mic's live.
I don't know if you can actually talk to him. It's not set up.
Yeah, I'm not sure either.
That was a question.
Jenny.
So what's the question of Jenny?
You're unmuting him?
Yeah, see if you can unmute her, Jenny. Yeah.
No, he's self-muted.
If you want to unmute yourself, Jenny, you can.
So if fuse is for 220 volt grounding, are you talking about which interface are you concerned about? The inputs or the outputs or the incoming AC power?
Click the little pop out.
Oh, input B and C.
Input. Okay. In 900 we have fuses on the input frequency.
Yeah, so this will work just like it does in the 9500 where we have protection up to just 200 volts peak. So if you connected it to a 220 volt, if you accidentally had it wired into 220 volts, that would likely damage the input, just like it would on the 9500.
Okay. Does that answer your question then, Jenny? Okay. And then, Holger, can you explain a little more about the transformer coupled ground isolation?
Yeah, sure. So that's on the digital output. So what happens there is we're able to, because it's a digital interface and it's running at a higher speed, we're actually able to transformer couple it inside of the 10500, as opposed to in some applications will require when we're using the analog outputs, will require a coupling transformer on the analog side. Those tend to be big because we have to deal with lower frequencies to get the bandwidth we want. But with the digital output, we can transformer couple that right inside the box, which means there's no ground reference back to the 10500 when you're connected into an amplifier at the other end. So if you have
some 60 or 50 hertz noise on the other end that will help to isolate that and keep that from bleeding back into the inputs.
Hopefully that answers your question, Lionel. Holger, I'm going to try to unmute you again. There, Holger, you can speak.
Do we have any other hands up?
So.
Or maybe it was a mistake from my side.
Oh,
Yeah, there we go.
We can hear you now. Do you have a question, Holger, or not?
So maybe the only question is now the converter from the digital to the analog output. Is it available from the beginning or it comes later?
That will come a little later. We're actually developing that right now.
Okay. So later means end of the year. Or what means
My
later?
goal is to have prototypes by the end of the year. So we're talking earlier next year to have that out as a product.
Okay. Thanks.
Thanks, Holger. Does anybody else have any questions on or for Brian? Otherwise, we'll switch to just the pricing. You guys are making this easy on us. You're supposed to drill us with questions. All right, thanks, Brian.
Yep.
I think that's it. Okay, so let's get into pricing now. It's pretty straightforward. So the VR9500 and the 10500, although similar, do not cost the same. So when you're buying a 16-channel 10500, the hardware cost is $9,000 USD. So just to put that in perspective, a 16-channel hardware cost for the 9500 would be $14,000. That is if you do $3,500 times 4. So initially, we're already starting with a $5,000 US dollar discount compared to the 9500. Also, it is our intention to not sell this as a system below 16 channels. So if somebody wants 12 channels, we will not offer them initially, or at least right now, a VR 10500 with only 12 channels available. So below 16, we still recommend the 9500. There's going to be kind of a point here, though, when you're at a 12-channel 9500 channel system, it almost makes more sense to get bumped up to a 16-channel. But that's going to be a decision that the customer needs to make. So if we look at, with the I/O software at a current $18,300 list price, a 16-channel system with no software, just the I/O and the hardware cost is going to be $27,300 USD. That is at list price. So the 9500 equivalent with $18,300 list price for the I/O software plus your $14,000 hardware cost, you're at $32,300. So that is a $5,000 discount compared to the 9500. This also then brings up the question of for you guys is when we import and ship it, the cost now on the invoice for hardware is going to just be the $9,000 if you're only getting a 16-channel system. So as you know, a few years ago, we switched to most of our distributors with hardware invoicing and then also software invoicing being separate due to VAT, tariffs, and whatever. So I see that there is a question here. A second. So the question is, which software version must we use for the 10500? So what is the initial release software? Is it going to be able to go back? 2020.4. They won't be able to use 2019 or.
But it's not 2019. I'm not sure which release of 2020 it is.
It'll be the September release of 2020.
Okay. So to answer, the question was asked is which version of the software is going to be the minimum for the 10.5, and it's going to be the software that is released in September alongside the controller release or the hardware release. So more than likely 2020.4 or whatever we're calling it.
Something like that.
Yep.
They're working on it right now.
So to put this also in perspective of how much we're saving, the 128 channel system for a VR9500 at list price is over $200,000. This now has an immediate savings of $40,000 just because we're saving money on hardware. So this is ideally going to get us extremely competitive with some of the other high channel count, high-end application systems that we're now going up against around the globe, whether that's M+P or your LMS or your Spectral Dynamics. We're coming in there a lot more competitive now just by reducing our hardware costs. So, other than the hardware pricing difference, what are some other future pricing changes? So right now, Dan Van Baren, myself, Jordan Van Baren, and our operations team are working on setting appropriate pricing for some different changes that are coming with the 10.5. So with that, and we don't have pricing set for this yet, but there is expected to be some changes to the dual phase software. We're not 100% sure how that's going to look, but ideally it'd be probably a reduced cost for certain things. And then also future pricing for new multi-access software. The question always is MIMO or matrix control. These are things that we intend to do in our own fashion. What that's going to look like is a question for Phil Van Baren, but that is going to then have a different pricing structure based on which software we develop. I can't really think of anything else for multi-access.
There's all kinds of opportunity here. One of the biggest issues we had in studies that we've done is the VR9500 requires outputs from different boxes, so the computer, the system generating those outputs are uncorrelated, and there's problems with that. So this new hardware is going to give us a lot of capability. Now, what we develop for software in what order is a whole different question. But I think the first things on the list are going to be getting the 4 independent outputs and then have the ability to do 4 phased outputs from the same box. That's going to be, and then the digital control output. Those 3 things are going to be the top of the list, and we will address additional things from then on.
Yeah, and as always, as all of you know, all of our development, or I should say 90% of our development, is driven by customer requests, distributor requests. So if you have requests right now, you can send them in, and it allows us to prioritize what we want to develop. And we have a fairly new product planning team, we call. It's about 7 or 8 of us on. And every 2 weeks, we basically look at what it needs to be prioritized for software, hardware development for VR. So along with multi-access, there's going to be different pricing for additional post-system purchase drive output. So if you buy one drive output on a 16-channel 10.5, but then you later want an additional output for, say, dual phase, there's going to be a difference in cost compared to what the 10 or the 9500 is. lower, higher, I'm not sure. And then the calibration, so factory cal, being that it's a 16-channel system with 4 outputs, there's different labor that goes into that, so the factory cal price will change, as well as the auto verify license. Even though it's only one box now, it's still 16 channels, 4 outputs, so we got to take those into account on how we price this. And I don't mean to share any of this with you to scare anybody. This doesn't mean the pricing's going up necessarily on everything. Just to show you that there is going to be future changes when we release the price list to you. And the goal is to get the 10.5 price list out here in the next couple weeks to all of our distributors. And then the final difference that is going to change going forward is the replacement costs. I mean, the board itself is different compared to the 9.5, as Brian shared. We moved some of those changes to the front input board, which then allows us to actually reduce repair and replacement cost. And we still intend on having the same hardware warranty standard or procedure as we do on the 9.5, so that does not change a whole lot for you guys. And then some additional information. So the pricing structure is going to remain the exact same as it does for the VR9500. I mentioned this only because our Observer 1000 pricing structure is set to a fixed 20% for distributors and reps, but the 10.5 will remain, either the trailing 12 months that all of you are on, or the fixed margin that some are on in different regions around the globe. So then this also then means that your margins will remain the same as if they were on the 9500. We're discounting it the same as we do. So say a distributor has a 20% discount, and if you look at how that discount is applied to hardware and software on the 9500, we are doing the same thing for the 10.5. So there's really not a whole lot of changes at all for the distributors. We have already begun quoting projects with the 10.5 with the assumption of delivery in September at the earliest. I think we've quoted 6 projects, a few of those in Europe, a few in Russia, a few in Asia and China, and I think a few in India, or 1 or 2 in India. So we have been quoting this product already, with the assumption that the system is not going to be available until September. And now, once you guys have the price list, it might make it a little more easy for you to quote product. One, I think, is an important part to point out, though, as well, is there's no input jumpers on the 10.5.
Good point.
So what this means is we don't need to adjust jumpers based on the amplifier and shaker we are hooked up to. That doesn't mean we don't want to know what shaker we're going on. It's nice to know, percentage of shakers, what brand we're on. We can do a lot of reporting with that, but as far as jumpers on the front inputs, that is not required anymore. I think there was maybe 3 or 4 different types of shakers. If we knew we were going on, we would adjust the jumpers so that the noise level was reduced significantly. And then finally, a new product release during an economic downturn, that's affecting all of us, is a good reason to get customers excited. Dan mentioned this to us internally, that the last time we released a product, which, a controller, was the 9500, and it was right after the economic downturn in 2008 that everybody here was a part of as well. And it sold great. It's a good thing to get customers excited for. We know budgets are being moved around and CapEx and OpEx is being slashed, but we hope that a new release like this can get some of those customers excited, get you guys excited for selling it, and hopefully be more successful with, I think the biggest thing is the reduced hardware costs to get more competitive in these high channel count instances. So that ends it for me. we're a little bit faster than we thought we'd be. But there are some questions. I'm going to pull them up a second. Are you planning to support charge sensors? So there's a few questions that came in. Are you planning to support charge sensors in new VR10500? I think that's a great question for Ryan.
Yeah, we still don't support charge sensors natively in the 10500, just like the 9500, where you would need some sort of charge amplifier to go in between the 10500 and your charge sensor.
There has been talk of maybe creating our own, but that's kind of just a pipe dream right now as well. But initially, just expect it to work like the 9500. Okay, so we got another question from Paolo. Thanks, Paolo. Are mixed configurations available? 20 channels, one VR105 and one VR195? That is not going to be available ever, probably. We're going to stick to the 10.5, working with the 10.5. I think this is probably a question you asked because there was one version where we allowed the 8500 and 9500 to be working together. At the time, that seemed like a great idea, but then when you have to stop supporting it, you're basically limiting customers to have to only operate their 9.5 and 8.5 on one version of the software. So to just kind of cut the cord right away, we just said, all right, no, 10.5s work with 10.5s, 9.5s work with 9.5s. And like we said, we're not replacing the 9500 in this new product release. We're just coming out with a better high-end, high channel count product that the 9500 was lacking. So thanks, Paolo. Hopefully that answers your question. Vasily asks, when will the price lists for distributors be updated? So most of the price lists are already updated. We're just waiting for a few clarifications. So I would hope to get those sent out to you in the next 2-3 weeks. And we're pushing for it to get them out as soon as possible. So it's really held up right now just in well, Kathy's the one who manages the price list, so she's the one who's getting all those questions answered right now. So a couple weeks, we'll get them to you. Next question. Do we have any plans for strain/bridge front end inputs? Another good question for Brian.
No, we currently do not. We've talked about it a few times, but I don't think we have anything in the works right now. Do you agree, Jade?
I do. Yeah, it's a conversation piece. The problem that we keep running into is that you can buy single channel strain/bridge conversion tools for $500 a channel, and for us to put in the time and effort to develop our own, we would be priced higher than that. So I don't know that we could create our own that is competitively priced.
Okay. I'm not seeing any more questions at the moment. If you want to raise your hand and ask a question instead of type it out, you can do that. I think we were maybe going to do kind of a little bonus. Oh, here's a question. Is a 24-channel configuration possible? That would be no. So you'd either be at 16 or 32 channels. Yeah, pretty straightforward.
But what does a 24-channel 9500 compare to?
Yes. So
32 channels.
That's a very good question. So in Wojciech, to answer your question too, okay, so if I had the calculator and the price list in front of me, I think the price for a 32-channel 10.5 is actually cheaper than what a 24-channel 9500 would cost. So if that's the logic you can use to your customer, they're getting more channels at a competitive price of what the 9500 would have cost at 24 channels. more questions? Oh, here's another one from Sergey. Thanks, Sergey. Is it a permanent not being able to order a 10.5 for, say, 12 channels, or will that later be changed? As of right now, there's no plans to say, hey, we want to offer 12 channels, 10.5s. That isn't limited, though, to anything that's done in the hardware. That's just a software key for us. But as long as we still have the 9500 available, we're going to have that be our 16 and below channel hardware piece. Hopefully that answers your question, Sergey. Okay, Holger says the 10.5 channel extension is only 16, 32, 48, and so on. Yes, that is correct, all the way up to 256 channels. And so, since we went a little bit quick, I did want to offer up to any of those who want to stick around for 15 more minutes. Jade did this really awesome ObserView software demonstration for the internal team here. We got some really cool new features on the Observer 1000 and ObserView software that's being released probably this week, maybe next week. So if you guys want to stick around for 15 more minutes, we got some cool new stuff to show you. Highly recommend it, and we won't take too much of your time. We won't go beyond the hour and 30 minutes that we scheduled for. So feel free to enter in more questions if you got any. You already remoted in.
No, I'm not.
Oh.
There we go. Alright, so I just got a quick remote desktop into my computer where I have everything set up. Just make that out of the way. Let's see here. And this one, I think, is the version that I want to use. So,
You can dock it with the large.
I'm just trying to make that a little smaller. Alright, so let's see here. So the first thing I talked about with ObserView, the big change for this release, which is going to be 2020.2, is the ability to connect to hardware and use it as a live analyzer rather than a pure post-process tool. So I can do that, connect to a device, configure hardware. Here I can see in the building we have all kinds of different observers available, Wi-Fi or not. When you're using Live Analyzer, you want to be connected via Ethernet cable, just because of the data stream. But inside of this configure hardware menu, I can also update my firmware, I can update the license key, all of that. And yeah, I can see what version I'm on. If I'm out of date, it tell me, all of those good things. So I'm already connected to my hardware, so I can hit close. And I need to set up, I have these all teed together, so I'll show you how this works here in a second. Essentially, I have my channel 1, 2, 3, and 4 from my 9500 teed into channels 1, 2, 3, and 4 of my Observer 1000. Just reset this a second. So once I have data coming in here, you should be able to see it now. We look at that. Once I'm connected, I now have the side pane called Observer 1000 settings, and this is identical to what we see in the mobile app. Let me just make this bigger now that I have it set up so everyone can see what I'm doing. So in this side pane, I have to stop my data stream, but here I can configure. this a little bigger so everyone can see it. Something like sample rate, recording file destinations, Wi-Fi settings, system settings, all of those normal things that we set in VR Mobile. I can also configure my inputs. And here is a great utilization of that 0 to 20 volt range. Now, capacitor coupled mode is not available for the Observer 1000. It doesn't exist. So instead, I have this 0 to 20 volt range, and then as you can see, my DC offset is filtered off, and we're only displaying the AC variation. So that's me using that 0 to 20 volt range. Here I have my sensors set up and 4 of them enabled. I can also watch my channel readings, so if I wanted to see the GRMS or if I had TAC set up, I could see my live TAC data as it comes in. So now if I hit play, I can see my live data stream. And if I quick create a test in vibration view, we'll just run, actually let's do something that moves, so new test, sign on random. And swoop up Alright, we'll do some sign-on sign for Holger. I'm just going to open up these limits so I don't have to actually configure anything to get it to run.
Not recommended in the lab.
No, don't do this for your customer, but I have some odd beams that are on top of my shaker, and most likely in order to get this to work correctly, I would need to do some manipulation or just turn off my limits. So now you can see my time data coming in. It looks a little rough on the screen because I'm remote desktop, but see that time data coming in. Here I have a live FFT that's showing. I can also look at peak hold FFT. So if I check that box, now as my sine tones start to move, I have the trigger set up. So as my sine tones start to move, you'll see those. If I zoom in here, you can see the peak hold FFT versus the current FFT. That also works for a PSD. So if I add a graph and look at the PSD, there's also a peak hold checkbox for PSD. Now, one thing that's happening in the background, I keep seeing my recording get started and then it's holding at 29 seconds. It's a new feature for the VR Mobile software that comes out with this same release of firmware. And VR Mobile in Live Analyzer, it doesn't really matter. I can get to triggering. And triggering allows me to set various events and actions. So in this case, I have, if my channel 2 exceeds 5 Gs and I am online power, so it's plugged in, if those two events happen, then it turns on my pin 2 digital output and records for 30 seconds. So it's just continuing to record. If I stop my test, sorry, that's not what I'm trying to stop. If I stop my test in vibration view so that I don't have any acceleration on channel 2 anymore, or it falls below that 5G increment, you can see that starting to count down. You have a whole bunch of options in here for different types of events. It could be the device startup, the state of an analog input, the state of a digital input, the current recording state, power state, or time of day. And events, obviously, you have start and stop recording or record for a set period. But you can also enable or disable the digital output, turn off the device, delay for a duration, whatever it might be. So that's pretty cool. Triggering is, they put a lot of work into making this interface very simple. but also very powerful. So, last thing I wanted to show, I got a little bit more in Live Analyzer. We'll get this up and running. And once I have some data coming in, there's a couple things that I want to show. First, there is a buffer of data, a piece that is being stored on the PC. I can change the size of that buffer in the time window properties. So if I wanted to save 20 minutes worth of data, it would require 2.34 gigs of data on my PC with my current sample rate settings. But that means if at any point all of a sudden I might want to look at, let's just add a graph, add the FFT. Now all of a sudden I see this moment of interest right here. So what I do is I just drag it over, highlight this segment. So now I'm looking at the FFT for this window. I can do my analysis, I can play, but I am still buffering the live incoming data. So if I hit play, I now have that additional 15 seconds of data that was missed because I had the stream paused. It doesn't get removed. We continue to buffer that data almost like a DVR feature for your television. I can pause and resume without losing any data, so long as I don't exceed whatever this buffer duration is set to for the available space on my computer. Last but not least is some changes to the spectrogram. So we've added spectrograms. Oh, sure. Continue. So let's just make this bigger. Here you can see I have a spectrogram set up for the time window that I'm looking at. See that moving. Some new things, I can have a mount or horizontal and vertical. That was in the previous version of the software. That I can have this cross section, so I can move that up and down and essentially see for this graph, since it's a time, it's essentially the FFT slice for that moment in time. You can also see the vertical. So if I wanted to align that, that gives me for a particular frequency how it changes through time. But now I can also view in 3D. And it builds that 3D spectrogram for me. Just turn these off so you can see that. So there's my 3D spectrogram. I can sync this or drop it below the floor so that I can only see points that I care about. And the cool thing is all of this, whether it be 3D, any of the graphs that you've seen can be copied and then pasted into a Word document for reporting. So that's kind of the quick, fast overview of, yeah.
I would say, can you explain to the guys then, like, why would they want to do this with their controller and have this option to live analyze it in?
Oh, well, so it's dual software. The new 10500 is a dual software platform. So the time history analysis and handling of a time history document or time history waveform is optimized in observe view rather than vibration view. This capability is simpler, it's easier to understand, and other things. One other thing that I can do is if in my buffer I have a segment of time that I want to export to a VFW for test generation later, I can just click this export data button, and there's a new checkbox here that just says export summary graph selection band, and now when I export that, it will create a VFW file that I could then use for FPS or whatever else. Primary tools, it's simpler, faster, and gives you a little bit more variability in that I can change analysis lines and change all of these things without losing data. So I can manipulate this and now look at it as 1024. I can view the peak hold. All of these are capabilities that we don't have in vibration view that we do have in this live analyzer. So more and more we are going to be adding capabilities to ObserView specifically for live analysis and post-process analysis that are beyond what you can do in vibration view because that is tailored to be a controller. So.
Good. So that is all we wanted to show you. If you guys have more questions, put them in right now, but thank you for your time. I know it's hard to get 30 or 40 people to attend a webinar at the same time, so I appreciate everybody joining us. One question, can we put live graphs to MS Word for changing cursor on Word?
No. I think I know what you mean. You want to be able to move the cursor in Word. Whether you know it or not, I think LMS does that. There is a lot of problems with allowing that. It is not very secure and forces you to leave some open doors into the software. And it's just
To communicate with Microsoft Word, yes.
Yeah, it's dangerous, and yeah, it just doesn't happen. When is the new version being released? So Vibration View, which is this version, which I was using over here, Vibration View 2020.1.4 was released yesterday. There's some new stuff there. I'm going to do a webinar. Most of the new stuff was we fixed a bug so that when you do SRTD and you want to control on displacement, the actual UL is controlled on displacement and not acceleration. We also added some more mil standard 810H stuff and individual channel tolerances stuff. We added some communication or some calculations to SRS for symmetric fitting and the new TE calculations that are defined in mil standard 810H. And we added a meter hertz unit to your velocity test units. But this is released already. You should be able to download that from our website. ObserView, I am looking at release candidates right now, so that typically means that we're in the final stages of development and we should be releasing in the next week or two, depending on how testing goes. Any other questions?
We got 5 more minutes if you guys want it. So, otherwise, we hope at least Ryan and I and a few other of us get to visit some of you guys soon. I don't know if that's going to happen with the current situation, but we do look forward to seeing your guys' faces again in the future. And if any of you have questions you want to ask offline, if you need more instruction or want more information, we'll always gladly do a personal webinar with any of you, as you know. Did you say that 10500 can be connected to ObserView? Yes,
absolutely. That is what is meant when we say it is a dual software platform. So it can be used as a live analyzer, the tool that I just demonstrated with my Observer 1000. You can do that with the 10500 as well. All of that same
Задаю вопросы. Вебинар называется.